So I just want to introduce myself. My name is Stephen Fulmer. I am a product manager within the Ansible BU. My compatriot here is Reza. He is the guru over at Nestlé Nespresso for all things automation. And today we're going to be talking about specifically around automation, event-driven automation. And with that, we're going to go ahead and get started. I want to raise of hands here. How many of you have actually played around with event-driven automation yet? Wow, quite a few. All right. So the reason why we came up with event-driven automation is that we saw that we have all these things that we actually automate, right? We have switches, we have servers, we have VMs, we have applications, we have security devices. Well, most people, their crux isn't really automation. It's going in and fixing an issue that may have happened that they don't really want to fix anymore, right? They have services that may have stopped. They may be out of compliance with the server. And we said, hey, how do we go ahead and fix that? And we went and created event-driven automation. So it is a single enterprise platform that will automate everything under the sun, pretty much. And it automatically responds to the changing conditions that we get from your observability sources. So that could be through a message queue like Kafka. It could be through Dynatrace. It could be through Big Panda. It could be through an Azure message bus. It could be through AWS, the same thing. And we get these messages and we say, through the rule books that we've created, and we'll talk about these in just a second, does it meet this condition? Do we need to fix this issue? And it will go ahead and fix this issue. We have actually a client of ours that went from a typical 90-minute restart service time to 9 seconds. That's the reality of event-driven. As soon as it gets it, it can go ahead and fix it for you. All right, so event-driven also integrates with ticketing system. So if you have a ticketing system such as ServiceNow, it will actually go ahead, create a ticket, go ahead and fix the problem, go ahead and update the ticket, and then close the ticket. Now, what happens if it goes ahead and tries to fix the problem but can't? It will update the ticket saying what went wrong. And then it can have a second set of eyes saying, hey, we're going to go ahead and need to fix this manually. So it uses the events to trigger the ITSM actual detection. And it will also update your CMD database. Now, I don't know if you're like most customers, but there's varying degrees of confidence in their CMD database. Right? You can create a webhook into whatever CMD database that you want. But the idea is that by doing this, it actually creates a more consistent and up-to-date CMD database for your environments with less drift. So let's talk about some use cases in depth. We have, we were talking about networking, we're talking about edge, we're talking about cloud. And we actually have native certified collections with these and amongst other vendors out there that we can create a certified webhook or a plugin into EDA from their vendor. We also work with Prometheus, Alert Manager, Kafka, amongst many others. And this also, because it's a Red Hat Ansible, you can also create your own webhooks and plugins to whatever source that you have. So you'll notice that, for instance, Jira isn't on there. I've had clients that actually created their own Jira webhook and did the same exact thing. So from a cloud standpoint, we can actually trigger cloud estate checks. I don't know how big your guys are in general, but people spin up cloud instances a lot without any checks or balances. This can actually do a check. If it doesn't hit a condition, not only can do a check, but it can also spin down the machine if it doesn't hit the priority rules. It can remediate tasks through the service bus. It can automate that troubleshooting, and that troubleshooting can still be the same as it is on-prem, as it is in cloud. If you have a server that's out of compliance, if you have services that are down, if your network's out of, if you've set up a wrong VPC or a security rule within your cloud real estate, it can actually work through your message, through your observability platform and fix those issues. Come on, there we go. From a network automation standpoint, this is actually one of the biggest One of the biggest things that we actually see with event-driven use cases, network automation, how many times things have actually changed that people don't know about, or how many manual tasks that people don't want to do from a network administrator standpoint. I was a network administrator back in the day. I didn't want to reset a VLAN, right? I don't want to, I don't want to change a reset a firewall rule or a VERF or something of that nature. So you can actually do fact gathering on your entire network automatically. Use those facts, and you can actually go ahead and fix those issues that you have. If the port goes down, what do you do with the port? It can bring it back up, or it can switch it to another port. You can do configuration and drift management. So if a switch is out of compliance, it can actually put it back into compliance. If you have a AP out there that's out of compliance, you can put it automatically back into compliance. So if you have a lot of, say, edge use cases, stores, retail, financial banks, stuff of that nature, you don't need actual human interaction if you don't need it, if you don't need to be there. And it also can address security risks fast. So if someone breaks in to your, through a firewall or something of that nature, or EDA can get notified through that particular firewall, and actually close down whatever ports, shut down machines without having any human action, and actually cuts down the mean time to resolution for that, thus closing the hole for those end users, for those miscreants, so to say, to actually get in and do anything nefarious. I like using the word nefarious, by the way. From an edge standpoint, we talked a little bit about that, right? From a networking standpoint, network and edge kind of bleed into each other. You can do basic to advanced Wi-Fi operations, full life cycle manage your edge computing, so not only from your switches, but your endpoint devices. And you can have faster incident response across that. And we're talking about pretty much any edge. Think retail, think manufacturing, think financial. We also have clients that are train operators. They actually have like a NUC on a train. They can actually do it there too. And the bread and butter of Ansible, you can still do the same exact things that you would do across the board. Fact gathering, basic to advanced remediation. We had a power company who had an LDAP server go down in the middle of the night. They did not know that it went down until they came and looked at their ticketing system, because EDA had actually brought it back up and no one knew about it without any user interaction. So no one complained in 3 in the morning saying, I can't get into the system. And so it addresses those security risks very fast. So how do we do this? So we basically have 3 building blocks. One is sources, and this is where the Dynatraces, the Big Pandas, the Kafkas, those would be your sources. We're gathering data, messages, logs, alerts from these sources. We're creating a rule in Ansible called a rulebook that still uses YAML. There's nothing really changed in it. The only difference between a rulebook and a playbook is you now have a what if type of condition. You still write in the same way, but you're going to be writing, if this is the condition, do this, right? If it doesn't meet this condition, don't do it until it meets this condition. And then you're actually going to be doing the action. So a rulebook will actually call a playbook. Playbook will actually do the action, and it'll update it, and the rulebook goes back to listening. So the biggest difference between a rulebook and a playbook is the rulebook is always listening for alerts. A playbook has a definitive start and stop. Okay? Does anybody have any questions so far? Okay. So this is a little bit more in depth. We have the event source. This is just an example of what the event source could be. You can actually put a message layer like Kafka in there. A lot of people do who utilize event-driven automation. Through the event-driven automation, it actually has a management interface and everything of that nature. It calls the playbooks. It integrates. At that point, you have the integration with the Snow module. It does the action. It updates the action. It closes the action, and it goes back to listening. So with that, I think we have Reza. You can have him talk now.
Thank you. Okay, so before I start with the use cases, first of all, I try to choose 2 use cases that I think it's going to apply to everyone's environment if you guys are going to start using EDA. The first one is related to meta monitoring. With a show of hands, how many of you guys had incident in your production and it has gone unnoticed because either the monitoring wasn't configured correctly, it had crashed, or it wasn't even installed? Don't be shy. I cannot read your badges to know. I'm going first. Okay. So this has happened to us. And when we started using EDA, this was one of the main focus for us. Because if you are using EDA, probably one of the common use cases is going to be that you want to turn those alerts that are coming from your alert manager, from your monitoring solution, to automated remediation workflows. Meta monitoring is basically the process of monitoring your monitoring solution. You are trying to make sure that your time series database like Prometheus is working, your alert manager is firing the alerts, and your monitoring agent is shipping the metrics, logs, and traces to the endpoint. Why? Because if, for example, if the monitoring agent crashes, no metrics, no alerts, no events. So this is the first use case we're going to look at with EDA. The scenario that we have, the monitoring stack that we're going to use in here, we are using Prometheus, we are using Alert Manager, which is the source of our events. It is already, there is already a module with Event-Driven Ansible for Alert Manager. We are going to use Grafana dashboards, and here we are using Grafana Agent, which is a free open source agent that you can use it to replace multiple exporters that you have for Prometheus. In this demo, you guys are going to see me using all of them in one interface because we are using a hosted solution. It's called Grafana Cloud. You guys may have an on-prem solution. It's going to be very similar concept. Now, this is how our setup looks. We are using Ansible AAP already to manage our infrastructure. We are using it to manage our monitoring solution. We are also managing it, we are using it to manage our observability stack. If you look at it, it's a two-way communication because we are getting the events, and you guys in the demo, you're going to see that Ansible is going to interact with our observability stack. And we have the ITSM solution, which in our case is ServiceNow. You may be using a different solution. So what is the example incident that we had? In our environment, we are using remote write to Prometheus. We had an incident that the credentials had expired. The agent was running, but it wasn't shipping the metrics because of the invalid credentials. At the same time, we had an issue that the disk was filling up, but we had no idea. We just noticed it once everything crashed. Okay. Here we're gonna see how we're gonna use EDA to handle this situation. But before going to that, you guys are gonna say that, okay, if the monitoring agent crashed, how do you receive an event or alert? This is where the magic happens. If you guys are using Prometheus, on-prem Prometheus, you are probably doing the scraping. You are setting up the targets, scraping the metrics. And if the node exporter or any other exporter is not working, you're gonna quickly notice. In SaaS solutions, it's a little bit tricky because you are shipping the metrics to an endpoint. Now, this can be hosted Prometheus, Dynatrace, any other solution. Usually in that scenario, you need to come up with some custom approach, meta monitoring of the agent. Most of the vendors nowadays, they have articles. You just need to look it up, how they recommend to set it up. This is the native Prometheus way if you are doing a remote write. You basically create a custom metric, you distribute it among your agents, and if one of the agents goes down, you know that that agent needs to report and you can alert on it. Again, at the bottom, there's a link to that whole meta monitoring if you guys are interested to learn more about that part. Now, this is our rule book. We are keeping it really simple. We are listening for the alerts from Alert Manager. If we get the alert that we are looking for, we are triggering a job template on AAP, and we are limiting it to that host. And now for the demo, I'm just going to record. I have recorded it, so let's just go with the recording. I'll try to. Okay. Here you can see our dashboard. You can see the monitoring agent that is already reporting. It is working, the metrics are coming in. What we're gonna do here, we are just trying to mimic the incident. We're gonna change the credential on the agent, and at the same time, restart the node to make sure that like everything now taken effect. We are also, cherry on top, we're gonna fill up the disk. So now if you look at the agent, there's a lot of mouse dragging. I was playing games and I forgot to adjust the DPI on the So now you can see that we have like credential errors. Quickly, let's see. Now we're gonna also check, and you guys gonna see that the disk var log is full, almost to a point that now Nginx soon gonna crash because it cannot write access logs anymore. So what's gonna happen in here? We have the alert already set up. I think a little bit of fast forwarding in here. So yeah, here you guys can see the same alert. You can see really, you can look at the custom labels. I don't know if in Prometheus you have used it. We are using some custom labels to redirect those alerts that we are already interacting with the EDA. If they have the EDA true label, we are sending it to the webhook that is configured on the EDA controller node. So I'm gonna fast forward really quick here to get to the point that you guys can see that, okay, now the agent stopped running. And if we go here, now we're gonna have the alert in pending mode. Then we're gonna get to the point it's gonna fire. Usually when your alerting system fires something, Alert Manager has grouping and some other functionalities that it waits for it to send it. So the delay that you guys gotta see here for the event to trigger in here, it's because of the Alert Manager, not because of the EDA. Now the event is triggered. If we go back to the, yes, our AAP, you can see that the remediation job has already been triggered. What this is gonna do, this is gonna go and run our Ansible role that we have. It's gonna put all the correct variables in place, and it's gonna restart the agent. Now, one of the things that we do, you guys gonna see what is called Grafana annotation. We are using EDA to add more details to our monitoring solution. You guys can see there that there is a link with the status that our remediation has started. You can click on it. It's going to take you to AAP, to the specific job that is running right now to perform the remediation. And once it's over, let's kind of do some quick forwarding. Yeah. Once the remediation is done, you can see that the status updated based on if the remediation was successful, because we are doing some checks for the agent. And there you go. The metrics start coming back. Now, do you remember we filled up the disk, right? So there is still another issue with the box. We got the monitoring running, but now look at this second issue. Now that we got the monitoring back up and running, now we see that the disk is full. Now again, it's gonna be the same thing. We are not gonna touch anything. This event is gonna again be triggered. It's gonna go to EDA controller, and it's gonna start the remediation for that job. So let me just, kind of same story. So, yeah, I was just saying. Okay. Again, going back to EDA, it's going to trigger the job. It's going to remediate it by cleaning up the access logs. In production environment, this is not going to be like as easy as we are showing it in here. You guys going to need to know your application, what you are doing, how you guys are remediating the second one. But the point is that we handle 2 incidents with very simple rule books, and playbooks. And now we are ready to process the rest of the events that's going to come to the system. And I think at the end, we also use EDA again for annotations. We are also, again, posting it to our Microsoft Teams channel, what EDA did. And at the end, we are also, I think, if I'm not wrong, we are creating a ServiceNow ticket at the end. Again, this part at earlier stages, it's going to be, you can kind of like use webhooks to use Microsoft Teams. In some of your companies, it's going to be a red tape to get API access to your ITSM solution. So just, it's not a blocker. You guys can start basically with what you have right now. Okay, I think we are ready for the next slide. But before I go to the next demo, any questions?
So you were talking about using Grafana annotations to show like what the automation did.
Yeah.
Are you using Grafana API for that?
Yes, it's Grafana's annotation API, and we are using just like Ansible code to dynamically, we are registering the result of our playbook. If it's successful, we are reflecting it there. We are using all the AWX magic variables that you can get the job ID and all of that information to like dynamically add it. And it's really like, it adds a lot of value. It's just something very simple, but adds a lot of visibility, especially for your operation team. That like when they see the incident, okay, they are aware of behind the scene, something is also happening. Let's wait for it to go through. Let's see if it's gonna fix it. If not, then the incident is gonna remain open, and you can just update it with another like API to like escalate it. No problem. And again, every other solution, here we were using Grafana annotation. Again, we went back to the same video. Every other monitoring solution, they have a similar functionality. I think in Dynatrace, they call it Markdown. Every solution has a similar functionality. Okay.
So one more question actually. So EDA, when you are detecting the event, there is a way to directly call the job template as well. I mean, what is the value proposition EDA is bringing here?
Well, I'll tell you what was our challenge before EDA. So we really wanted to connect those alerts to automated workflows, and the payloads that we had were different. The webhook that is coming out of Alert Manager is not compatible with Ansible Automation Controller's API. Okay, you always needed a man in the middle to kind of just like wrap this webhook. In our case, we were using Azure Logic apps to like do it. But it's, again, that was like really custom per alert. You needed to expand it. The thing about EDA, that the part that it really brings value, it standardizes it. All of those labels that you were seeing in alert, all of that is being parsed by EDA. You can use it in every part of your logic.
The EDA is transforming that as well.
Yes, it's doing all of that part for you.
Thank you.
No problem. Okay, so the next example. How many of you guys are familiar with this architecture for AAP? How many of you guys are using it in your environment for high availability? Okay, it's quite a few of you. Okay, for those of you who are not familiar with this architecture, I think if I'm not wrong, it came out with, it's a reference architecture that was introduced with AAP 2.1. The main focus in here is having a high availability Ansible. If in your environment, until today, Ansible is not considered a mission critical component of your landscape, the moment you guys start using it for incident handling, it automatically becomes a mission critical component of your landscape. So you want to guarantee its uptime and its availability. Usually what happens if you don't have this setup, if you want to patch your boxes, if you need to update AAB, you're gonna have a downtime. You can use this architecture to overcome those limitations, because you can fail over to the passive cluster, do whatever you want to do, the active one, and then revert it back. Now, this one is dependent on configuration as code. Everything that you do with this one is that it's basically configured and managed via configuration as code. We are not doing any backup or anything. And here we're gonna use a scenario that we're gonna basically cause one of our active cluster fail, and we're gonna see how EDA can help with AAP failure itself. So this is how our setup looks like right now. We have our site A, site B, which, full disclosure, these are our production clusters, okay? And we have the EDA cluster, which we haven't rolled out in our production because some of the features are still not in GA. But for now, we are receiving the events for both of those clusters, and we're gonna handle it with our dev cluster that we have in here. Our future design is gonna look like something like this. So basically, events from site B is gonna go to site A AAP to remediate the issue, and vice versa. If you guys are really into like Prometheus and you guys have done high availability with Prometheus, it's something similar, that you use one Prometheus to monitor the other one, and the same structure. Now, our scenario that we're gonna have for this incident, if you guys are familiar with AAP architecture, there is one single point of failure. That, like, if you take it out, nothing is gonna work. And that's the database right there. So that's what we're gonna target here. So this is again, the simple rule book that we have created. We're gonna focus on very specific incident in here. We're gonna cause an outage for our database, and you can, down the road, you can expand it. You can basically monitor all of your controller nodes. You can have condition based on the rate of 500 errors that you are getting. You can expand it in the rule book to different conditions. Now, let's go with the demo. Okay, here, as you can see on the top, our domain ansible.nespresso.com. On load balancer level, this is always pointing to our active cluster. And you can see that we have it on there, cluster A. We are using some of AAP's features to also flag it, which one we are using. Here, since this is our production instance, we are not gonna try to cause too many sessions or anything. We are just gonna gracefully shut down Postgres. Now brace for impact. So you can see our active cluster Ansible-A. Now it's out. Everything is 500 errors. Our load balancer also is pointing to the broken cluster right now. Our cluster B is still up and running. Now we're gonna go back to our monitoring solution. This is the alert that we have. We are looking for Postgres service. We have the Postgres exporter installed. We are monitoring the health of Postgres. Soon this is gonna report that it's not working. We have already stopped receiving metrics from the cluster itself. Cluster A stopped working, so no metrics coming from the cluster. Cluster B is up and running. So let me just speed it up a little bit here. So our alert is gonna fire slowly. Now we have the event. Event is triggered. Our remediation playbook is gonna start running on our dev cluster, which is gonna trigger a job on the standby node. Now you guys gonna see something happening on cluster. As you can see, our failover has already started. We are creating an incident because this is a big one. This is the payload of that event that we're gonna use. Moving forward, you can see that there was a first variable line 2, failover to B. I'm gonna show you, going back to the rule book, I'm gonna show you how we are detecting that. Now, If I go to the passive cluster that we want to take over, now you guys see something really interesting. There is a lot of like project updates are happening. The reason for it is that when you have Ansible in a passive mode, you are still using your automation, your inventories, your projects on every job run, depending on how you have set it up, it is updated. Now when you want the passive cluster to take over, you want to make sure that all of those inventories, those playbooks, those projects are updated. So while you are failing over, you guys also need to like push and update on all of these projects. Again, here we have the annotation that has been created. We're gonna do some basic checks. We're gonna make sure that site B is updated. We're gonna use HA proxy socket interface to quickly fail over to cluster B to minimize the downtime. Then we're gonna run the whole Ansible playbook to make sure that all the HA proxy config that we are putting is permanent there. It's gonna take some time until this incident is over. Once the playbook finishes, you can see that now ansible.nespresso.com is pointing to cluster B. Now, if I go back to the remediation playbook, the Grafana dashboards here, okay. I want you guys to look at that time in the annotation. With the help of EDA, we failed over our whole AAP cluster in less than 4 minutes from the moment we received the event. 4 minutes and you are already on a cluster. All your automation backend is working. All of the API requests are being processed. Basically, minimal outage. And these are the two that we are already using in our environment. So that being said, I think, again, with this one, this is a bigger one. We create an incident. With this type of incident, we usually don't automatically close it because you need to know what happened with the Postgres. But again, it's a custom decision that we have made. That being said, that's the end of our demo for this one. I've just a few recommendations for some of you that you are new to event-driven Ansible and you guys want to start. Start with simple use cases. Don't try to overcomplicate it. The way we started with the incidents that we had clear runbooks. We knew that what are the steps to remediate those incidents. We turned those runbooks to playbooks. So we can like automate it with Ansible so we don't do it manually. Then we looked at the condition that these playbooks need to be triggered, and we built the rule books based on that. Again, event-driven Ansible complements your existing landscape. It's not something separate. You guys don't need to start from scratch. You guys can use the existing content you have. Some of the use cases you can even don't need to build any collection or role. You can use the already Red Hat certified content or RHEL system roles to really address common use cases that you have with common incidents that you have in your environment. Also, build your content with EDA in mind. Again, don't duplicate the content too much. You can basically create the same role or collection to install and configure your application, then add the part that is for create annotation, create incidents, and use tagging, that whenever the events are coming from the EDA, enable those tags to basically expand the playbook. Also, actionable alerts. Again, you guys gonna have some alerts that are information that you really cannot really act on them. They don't have a clear runbook. Go with the simple use cases, simple alerts that you know what you can do there. And also use EDA, as you saw, to interact with your monitoring solution. That is, while it looks simple, it's very powerful. It has helped us a lot in our environment. I think that's the end. And I made it on time.
Drag out.
Thank you.
So just to close everything up, we wanted to make sure that it was open. So it's based on open source technology. It's flexible, so you can use pretty much whatever event source there is, as long as there's essentially an API. It's use case friendly, as we talked about before, and it is familiar. It's almost exactly like a playbook, so you don't have to learn a whole new language. And it's simple. So you can have a choice of automatically doing it or initiating manual interaction. So if you have an ITSM and EDA detects an issue, you can actually make it wait for a person to actually approve a change to happen. So it doesn't necessarily have to do it automatically, but you can say, wait for this to happen and work with that. We also have resources. I know you can't click on links through your computer screen, but we have multiple links. I believe this will be on our webpage at some point, if it isn't already, the links for this. So there's blogs, there's web pages, there's free self-paced labs through the Instruct platform. And I would like to thank you. Do you guys have any questions for either of us? Marco, can you go back there? All the way in the back. Yep, right there. We want Marco to run.
How do you synchronize the database from cluster A?
We don't. When you are using configuration as code, it completely eliminates that backing up and restoring the database. All of your job template, anything, any content that you have within AAP is configuration as code. We can actually completely destroy our cluster and rebuild it, and config as code is going to put all of the job templates, inventories, everything back in place. That's the thing about the config as code implementation. That's a requirement here.
Thank you.
No problem.
How do you handle credentials in that situation? Because you probably don't want to store those as code.
How do you store credentials?
Again, if you use, I'll provide the link for that configuration as code because it has the same like config as code. All the credentials that you are storing in AAP, what you're gonna need, you're gonna have a separate key, a vault key that you guys gonna encrypt all of the existing credentials, so they are not gonna be unencrypted and visible. But all of even the credentials, they go in as configuration as code. Even our logo that we put on our login page, you can turn it to a hex, binary hex, and like you can put it as a config as code. I think we have like 6,000 line of config as code because we have turned it to the hex and just like config as code, everything.
Backup and restore mechanisms like backing up?
We have it, we have never used it. 3 years of we are using configuration as code, we have never gone back to, using backups. And gonna be honest in here, we have never had any issue with Postgres in our environment that is like, it has been related to Postgres itself. It was like a disk space issue. Again, what I mentioned, we had like not good monitoring on that part and we fixed it.
And I would like to say that these demos that he actually did are actual real life, right? So he actually complained to me earlier about this, that this actually happened. I said this would be a good demo to actually do.
Hey, yeah, I had a question about the configuration as code part. If you've got additional users, I mean, so basically what you're saying is you've enforced, at least from the get-go maybe, even the consumers of your Ansible automation platform to implement all of their stuff with configuration as code as well.
We have a whole dedicated team who manages every aspect of our AAP, all the content that it goes. And we have the whole thing as a config as code. So any new job template that needs to go there, in fact, none of our users, they don't even have direct access to create it. We, like our main admin accounts, instead of the built-in administrator role, we use the auditor role so they can see all the configuration. But if they want to add a job template, inventory, they are supposed to go through the Git process, create a PR, that like the job template, whatever you want to add, it goes through the approval, gets merged to the master, it gets pushed from our CI/CD pipeline.
Man, I wish we did that from the beginning for us. Jeez.
Anybody else?
This last one.
Yeah.
Have you ever thought about considering
Well, in our company, like our team is.
Hold on, the people in the back don't see that. The question is whether or not his company had considered utilizing Ansible as a service.
That's what we are seeing and the need for, that we need to have a dedicated team to manage Ansible infrastructure and push, we started like community of best practices. We started putting automation around it to validate the content. But to be honest, you're gonna need to, if you want, you have a multi-tenancy in your environment, it's not gonna be sustainable if you just give everyone access to go in, create a job template you want. No, you wanna have a central team who basically provides Ansible as a service to the rest of your organization. That's what we have in place. But it came gradually.
One last thing, we actually have cards where you can QR scan the material that I had, on the majority of the material I had on the slide deck, so you can actually access it right now rather than waiting potentially when it gets uploaded to the website. Right here, so if you come up to the front after the presentation, I'll be more than willing to give this out, or you can scan it. We actually should have put it on the slide so you could scan it, but.
You're good. Thank you, guys.
Thank you very much.
Hope you learned something.